session. Yeah, 1 minute. Okay, so here guys, good afternoon guys, welcome back to NEET World Institute and NEET World YouTube channel. Yes, in today's class we are going to start, going to continue with the EAPCET session. That is, the topic is mechanical properties of fluids. Okay, yes, I hope you that you know the meaning of fluid. No issues, if you don't know also I will explain you. Okay, so fluid is nothing but, when you talk about a fluid, I guess it's clear, right? Yeah, I guess it's clear. So fluid is nothing but, it's liquid and gas. Okay, we have seen about a solid. Solid is nothing but, yeah, it's a particle which is closely packed, whereas fluid a particle which are loosely packed. So it is liquid as well as gas. Got it? This is the basic idea about a fluid, and we have talked about a solid, that is mechanical properties of solid we have talked, right? So there we have studied about stress, strain, Young's modulus, like modulus of rigidity and elasticity, everything. No, so we are going to study the similar properties which is in the fluid, like a pressure, Pascal's law, etc. Okay, so let's go into the topic. Okay, so first of all, so introduction for this topic is, if you see here, fluid, a substance fluid is called as a liquid as well as gas, as I told you, and for simple term we can say that which has a tendency to flow, which has tendency to flow. Right now this is the thing. So fluid has no definite shape, it has no definite shape, it occupies the, like it will take the shape of the object. Okay, it will take the shape of the object. This is the thing. Got it? So this is the thing about the shape. When I talk about a solid, no, it has a proper shape. Okay, and the volume of a solid, a liquid or gas depends on the stress or pressure acting on it. So when I talk about a solid, we are talking about a stress. When I talk about this fluid, no, that is a liquid as well as gas, we are talking about a pressure, right? Solid and liquid have much lower compressibility, like compressibility is high in gas. This is the main thing. Okay, so when I talk about a compressibility, it is high in gas compressibility, whereas this is low. Solid and liquid have low compressibility compared to the gas. Okay, and the next point is, shear stress can change the shape of a solid keeping its volume fixed. So shear stress can change the shape of the solid, but volume will be fixed here. Okay, the shape of the fluid changes by application of very small shear stress. Okay, that's the major thing you need to know about the shear stress, like for the solid as well as liquid. Okay, so this about the intro part. Okay, a small glance of the fluids. Okay, so in basic classes, no, you would have studied about a fluid which is nothing but liquid or gases, right? No, like solid, liquid, gas, we have studied about the basic terms, but when we talk about in this class, no, we will study some more deep. Okay, Now the thing starts here. So there we have talked about a stress, no, in solid. Here it is a pressure. Okay. So the first topic is pressure here. What is pressure? It's a normal force. And listen guys, the thing whatever I am going to tell here, no, like I'll tell the important things and we'll solve some problems. Okay, like EAPCET problems, right? No. So before that I'll introduce some example problems for you to easy to understand, right? So we will see the glance of the thing and we can take the formula from that and we will proceed with the problems, right? So normal force acting per unit area, force per unit area is called as force. And what is the unit? SI unit of the force. Okay, force is Newton and area is meter square. Is this similar SI unit for stress also? Yes, but the one more thing we can call it as Pascal. Okay, either we can say it's a Newton per meter square or else Pascal. Okay, that's the thing. So pressure is nothing but a force by area. So F is the magnitude of normal force of a piston of area A. We have taken a pistons, okay, and it's area A, like force has been applied and area A of the piston, okay, right. So average pressure is nothing but pressure average will be equals to force by area, the sum of force by sum of area of that given object, right. Yeah, you can take this. And very important thing is, what is 1 ATM? What is ATM means? ATM is nothing but where you are withdrawing money, not that ATM, okay. See, the ATM is atmospheric pressure, okay. So 1 atmospheric pressure, that is 1 ATM, is nothing but 1 into 1.013 into 10 power 5 Pascal. So basically for calculation purpose, what we are going to take is approximately 10 power 5 Pascal. Got it? 10 power 5 Pascal will take. Okay, don't get confused between the ATM which we are withdrawing the money and this ATM. Okay, that is different and this is different, guys. Okay, here you can take a note of this and we can go for the next one. Once you have completed, we can go for the next one. Okay. Hello. D will come. Okay. So the next topic is like the glance of the next topic we'll see. Okay, yes, as I said, SI unit of the pressure is Newton per meter square, or else we can talk it as Pascal. Okay, and the major thing, like what will be the dimensional analysis, like in like units and dimensions we have read about dimensional analysis of each and every terms, right? So here is the dimensional analysis of pressure. Okay, it is m L power minus 1 T power 2. We can say it is like this also, m power 1 L power minus 1 T power 2. So which should be mentioned in a square bracket. Okay, and see, some of the guys know like m power 1 L power minus 1 T power 2 like was there in a similar option it seems, but the bracket was like this, and we should not keep this as an answer, we should keep this as a answer. Okay, and when you talk about the pressure is equals to force by area, no, when area increases, what happens to the pressure? We should take the proportionals, like pressure is directly proportional to force and pressure is inversely proportional to area. Here area increases means pressure will be decreased, and if area decreases means pressure will be increased. When I take this a sharp edge, no, like the sharp edge area will be very minute, like very small, but when I talk about the flat surface, right, flat surface, and if I take this flat surface and when I take this a sharp edge surface, no, and if I keep both of them in and, like if we keep both of them on the and, no, which one will impact more? Yes, obviously the area which is less, right? No, yeah. So more pressure as a smaller area, less pressure as a larger area. Okay. So in absence of flow of pressure in the fluid must be same everywhere in the horizontal plane. See, listen carefully. In the absence, see, in the absence of flow of pressure, like when a liquid is not flowing, right? For example, when I take a container like this, and like it's filled with water, for example. Okay, like when I talk about this horizontal line, okay, this horizontal line, whatever the particles pressure, like presence here, no, like every particle will be having the same force in the horizontal line. Okay, when they are same, when absence of flow is there, when there is no flow, right, when then only I can say the pressure is same in the horizontal line. But what about the vertical? Yes, it will change. That one will come across in the upcoming slides. Fine. Suppose the pressure were not equal in a different part of a fluid, then there would be a flow. If pressure is not same in this axis, no, like obviously we can assume that, yeah, it is like there is a flow of liquid is there. Okay, that's the thing. So this is about the basic idea about when I talk about horizontal as well as the vertical thing. So in vertical, obviously the pressure will be changed, but when I talk about horizontal, no, like each layer will be there. So some particular layer I have taken, so this will be some horizontal line. So in this horizontal line, whatever the particle, whatever the point we are considering, that point will have the same pressure when there is no flow. But when there is a flow, pressure will not be equal. It is not equal. Okay. Got it? So okay. So next one. So what is the difference between the force, thrust, what is the pressure? Like some of you guys will have the terms like difficult to identify what is the term called, right? What is the meaning of thrust? So the thrust is nothing but it's a total force acting perpendicular to the surface. When a force is acting perpendicular to the surface, it's called as thrust. So what is that? It's a vector quantity. It has both magnitude as well as direction. So thrust is nothing but it's a force. It's a force, that's it. But what type of force? Perpendicular force. Okay. So what is the unit? It's a Newton. Right. So this is about the thrust. So the next one is, yeah, major difference between the thrust and the pressure. What is the meaning, like a difference between thrust and what is the difference between pressure? Yeah, I have given a simple tabular column, okay, to understand about thrust and pressure. So when I talk about definition of both thrust and pressure, no, like total perpendicular force acting on the surface, but whereas force acting per unit area, okay, this only force and this is force per unit area, whereas force is pressure into area, like pressure is force by area. It's a vector quantity, it's a scalar quantity. Okay, remember, it is a vector, but it's a scalar quantity. So unit is Newton, it's a Newton per meter square, or else Pascal we can say, right? So it depends on magnitude of force, it depends on both force and area. When I talk about a pressure, no, like force is there, area is there. So it is depends upon the force and area. And example, the force of water on the dam wall. When I take a dam, no, like a wall is there, like water will be coming and hitting perpendicularly, no, right, no, perpendicularly. So pressure exerted by water at a given depth. So for example, any container I'll take, like water is present here. So if I talk about any point A, B, C, or this point also, any point if I take, pressure will be there, depends upon the height. Okay, depends upon the height. Got it? So this is the basic difference between the thrust as well as the pressure. Okay, got it. We can go for the next one. Yeah. So we'll see some of the characteristic, like properties of the fluids. So this might help you in a theoretical way. Okay. So simple points I will say. You can note that points. Okay. So it has no fixed shape. First point, it has no fixed shape. Second point, if you see, definite volume. It has definite volume for a liquid. Okay. And third one, it is ability to flow. It has ability to flow. So first 3 points. Like no need about this. Okay, like no fixed shape, definite volume is there, and ability to flow. 3 points. Got it. And when I talk about the fourth point, exert pressure in all direction. So pressure will be exerted in all direction. If I take any particle, so pressure will be this side, this side, this side, every direction pressure will be there. Got it. So density and viscosity is the major term will be used here. Okay, density and viscosity. Like when I talk about stress, no, like force, that is mass, acceleration, that those kind of things we will use. Whereas here density we will use, viscosity we will use. And compressibility, we have talked about compressibility. No, liquid are almost incompressible. Gas are highly compressible because of larger intermolecular space. Like gas, no, like if I talk about gas, like intermolecular space are more. Like space between the gas particles, like each particle will be higher, like then liquid little bit less, solid it's tightly packed. Okay, yeah. Like 7th point is surface tension will be there, and 8 is buoyancy force. Buoyancy force we have studied in like lower classes. When I take an object, keep in a liquid, so it will give opposing force. Like opposing force is nothing but a buoyancy force, right? No. Okay, got it now. So it's buoyancy. Next one, this is the problem, one of the problem here. I'll give a, yeah, you can try this problem. Two tie bones, each of cross sectional area, that is how much they have given, 10 centimeter square, support the upper part of a human body of mass 40 kg. Okay, estimate the average pressure sustained by the femurs. Okay, femurs, that's the thing. So when I want to calculate the thing, no, I need to calculate for these two legs, like not only the separate leg I need to calculate, like I need to calculate for two legs. Okay, so take a minute and you can solve this problem and we'll see the answer for this. Completed? Okay, so whoever watching, no, you can give answer in the comment box, so we'll check the answers. Okay, so whenever you are solving, try to see the units also. Like some of the guys, no, they have not seen the units, like it has been given in centimeter and it has been given in a kg, like NKS, right? No, like a meter, kilogram and second, and CGS, centimeter, gram, second. Okay, so we need to convert that unit, like either you can convert to CGS or MKS, like depends upon the option whatever they have given. Okay, we'll see the answers now. Like cross sectional area, like they have given in a centimeter, no, we have converted into meter. Okay, so centimeter to meter it is 10 power minus 2, right? No, so 10 power, like centimeter square, so it is 10 power minus 2 the whole square, which is nothing but 10 power minus 4. So 20 into 10 power minus 4, that's the thing, right? So now if you see, the force acting on a femur is 40 kg weight. What 40 kg weight is the thing, because like the weight we are talking, like the, right, no, like the force we are talking, they have given mass, but what is force? Force is nothing but mass into acceleration. Mass they have given, but what about the acceleration? It is depends upon the gravity, that is weight, mg, right? No, so 40 into 10, like 400 Newton we will get. So we got area, we got force. What is the final thing? Pressure is equals to force by area. So force is 40 into 10 and area is 20 into 10 power minus 4. So finally you will get as 2 into 10 power 5 Newton per meter square or Pascal. Okay, is the answer for this question. Hi Srinivas Rao. And why we have taken here 2 times? Any idea? Because we are talking about the 2 legs, right? So 2 times we have taken. Yeah, I left long back, man. Okay, fine. We can go for the next one. So the next is density. So density, like the relation between density, volume and the mass is nothing but, so density is directly proportional to mass and density is inversely proportional to the volume, right? So density is nothing but mass by volume. What is the SI unit? Mass is kg, right? And what about the volume? So volume, when we are talking about volume, no, like when I take a cube, okay, simple cube I'll take. So if I talk about the area of the square, okay, area of the square is nothing but a square, like area of anything we will talk about length into breadth, like that. But like a cube is there. When I talk about a cube, obviously I'll talk about a volume. So a into a into a, like cube will take, no. So what about the a, like how I will measure that side? I will measure in terms of meter, right? So a is meter, like what about a square? It is meter square. Similarly, it is meter cube. So kg per meter cube is the SI unit, and dimensional analysis is given as m L power minus 3 and t power 0. Okay. So how we have got is mass, like that kg is denoted by m, and what about the meter? L cube. Okay. And whenever we are talking about the dimensional analysis, we should talk in terms of m power a, L power b and t power c. So m is here 1, no, m power 1 is there, and what about L? Minus 3 I should take. When denominator goes to numerator, it is minus 3. And what about the t? T is not there, so t power 0. So anything power 0 is 1. Okay. So no need to worry about t, it's t power 0. That's the thing, and it's a scalar quantity. And we need to know some values of the density, which is nothing but water as well as air. So volume of, density of water is 10 cube we will say, like 1000 kg per meter cube or 10 cube we will say. Okay. And air is 1.29 kg per meter cube, right. You can take this, okay, you can copy down. Okay, done. So we will see the next topic is Pascal's law. So its application of, okay. So what is the meaning of Pascal's law? Like the pressure in a fluid at rest. Like what is the meaning of that? Pressure in a fluid at rest. So when I take a container, in that I will fill some liquid. Okay. Now the container is not moving, which means the liquid is also not moving, right? That's the thing. Okay. The fluid is at rest. Is same at all points if they are at the same height. The meaning is, in the previous two slides, no, like we have talked about the horizontal thing. When I talk about the axis, this axis, okay, the horizontal axis, okay, if I consider any point, either A or point B or point C, everything is in the same line of axis, right? So in this case, I can say that point A, B, C are having same pressure. Okay, but if I take the line of axis in terms of vertical, and if I mark like this point A and point B and point C, okay, so depends upon the height, okay, depends upon the height, the pressure changes. Why it changes means, like when I talk about the force, no, when I talk about a force, like it's directly proportional to the gravity, right? Right, we are talking about acceleration like gravity. So here in the y-axis, that is vertical component, when the height varies, pressure also varies. But in this case, height is same here. Right now, it is lying in the same line of axis, so pressure will be same. Okay, that's the thing. Same at all points if they are in the same height. Got it? So if it in this diagram, no, we have talked about three forces like A, B and C, like side A, B and C. Okay. So normal force acting on the face BEFC, that is area A we have taken AA, okay, and similarly FB and FC we have taken, which is the normal force acting on the other sides. Got it? So if you see here, like, yeah, we have taken the diagram, okay, we have taken the diagram and we have talked in terms of equilibrium condition and the geometrical condition. So in equilibrium condition we have taken the components, so angle is acting in this direction, no? So whenever theta is close to the axis, we will consider as a cos theta, and away from the axis sin theta. That's the thing we have studied, right? So in the geometrical point of view, AB sin theta, no, will be equals to AC, and whereas AB cos theta will be equals to AA. And here by the equilibrium condition, vertical side should be equals to, like, vertical side and horizontal side we should take. So here horizontal side in the sense FC and FB sin theta and FB cos theta and FA, okay. So by these two comparison we are dividing the equations, okay, we will divide this equation and these equations, okay. So these two and these two we will take. So now if I talk about FB sin theta is equals to FC and AB sin theta is equals to AC, when I divide these two equations, so let me consider this equation 1, 2, and this is 3 and this is 4. 1 by 3 and 2 by 4. So 1 by 3, what is the relation we are getting? FB by AB will be equals to F by A, like force by area, force by area. Similarly we are getting here force by area and force by area. This is for C, I mean B and C, and this is for B and A. When B is equals to C and B is equals to A, I can say automatically A is equals to B is equals to C, right? So pressure at A, B, C are all are equal. So it's by Pascal's law. How I can say? When the fluid is not moving and when they are lies in the same height, that time I can say the pressure is same, okay. Take a note. Completed. Can we go for the next one? Now, so in the previous case we have talked about the horizontal condition. Now we will talk about the vertical condition, okay. So vertical condition in the sense we will talk about 2 points. One is the highest point and one is the lowest point, okay. So the highest point we will consider as a atmospheric pressure and lowest point we will take inside the liquid, so which is having the height h, okay. Now when I talk here, no, like first thing, the force will be acting in this direction and opposing force also will be there. The opposing force plus the buoyancy force will be there, like the buoyancy force is the thing, okay. When I take an object and when I keep in a liquid, so it, like, due to gravity it goes down, right? Now due to gravity it goes down and one more opposing force also will be there, and weight of the object is mg. So which are the forces are in the same direction? F1 and mg are same direction and opposing force is F2. So can I say F1 plus mg is equals to F2, and we know that what pressure is equals to force by area, whereas force is nothing but pressure into area, right? Pressure into area. So I can say force 1 will be equals to pressure 1 area 1, whereas force 2 will be equals to pressure 2 and area 2. Got it? So P1 A1 plus mg is equals to P2 A2, and I'll take this term this side, which is nothing but P2 P1 A1 or P1 A minus P2 A will be equals to minus mg. So if I rearrange this one, I can take P2A minus P1A will be equals to mg. Got it? Right now, and when I talk about the mass, mass. So in terms of density, how I can take density equals to mass by volume. Got it? Volume. So what about the volume of this cylinder? I can say area into height, na? Area into height. So here I can take this as mass is equals to density into volume, and density is nothing but area into height. Got it? So I can say mass in terms of rho AH. Got it? Now I can take this mass, I can substitute here. So rho AH into G, and I can take this A commonly outside, and A will get cancelled off. So P2 minus P1 will be equals to rho GH, whereas P2 will be P1 plus rho GH. So we have considered P2 as the lowest point, and we have considered P1 as the atmospheric point, right? So we have taken P1 as atmospheric point and P2 as the lowest point, right? What is the atmospheric pressure? 10 power 5. Got it? So and P2 will be equals to P1 plus rho GH, and we have talked about this P2 minus P1 as a gauge pressure or gauge pressure, we will say. Okay, so gauge pressure is the same formula we are using. So P2 minus P1 will be equals to rho GH, or delta P will be equals to rho GH. So this is the pressure in terms of depth, that is in a vertical component. Yeah, take it. Done. Can we go for the next one? Yeah. So it's just one of the application of the fluid, okay. Hydrostatic paradox, okay. So whatever the shape we are taking, if I consider this point, this lowest point A, B and C, okay, A, B and C, so the pressure will be same, at point A, B or C. Or if I take this line of axis, if I consider this is point A and this is point B and this is point C. So if I talk about the height, this height is h, here also the height is h, here also the height is h, right now from the ground surface, okay. So when I talk about any line of axis in the horizontal, like it can be any shape, object can be any shape, the pressure will be same. So PA will be equals to PB will be equals to PC. So the pressure at a given depth, it does not depends upon the amount of liquid present in it and object type also, okay. So pressure at a given depth is depends on nature of liquid, second one is depth and effective acceleration of the liquid. Here no acceleration, right? No, so height is same, right? And nature of the liquid, like liquid is similar, like if liquid changes, pressure also changes, okay, because liquid, like different liquid having different density. Like if I talk about the pressure, change in pressure, which is directly proportional to rho GH, so it depends upon the density and gravity and the height, okay. Yeah, you can take a note of this. Can we see a problem now? Okay, completed. So here is the question. So what is the pressure of on a swimmer 10 meter below the surface of the lake? 10 meter below the surface of the lake, no, surface of the lake in the sense I should consider the surface point as atmospheric point, right? So can I give answer for this question? You have a solid 1 minute time now, fast. So you can take a approximate value, like no need to take 1.01 into 10 power 5, you can take approximately the 10 power 5, okay, and you can calculate it. So I need to talk about this pressure, right, 0.2, right. What is the formula we have discussed? P2 will be equals to P1 plus rho g h. What is P1? It's atmospheric pressure. So I will write that P1 is nothing but atmospheric pressure. So P2 will be equals to, what is P1? It is 10 power 5. We have taken approximately. Okay. No need to worry about the 1.01. Like in the option, we can take the closest to value. Okay. So plus, what is the density? 10 power 3. Like density of the water, no, we are talking. Yes. So 10 power 3 and gravity 9.8 meter per second square. Take approximately 10. And height is, how much they have given? 10 meter below. Okay. So 10. Got it. So it is 10 power 5 plus 10 power 3, 1 and 1. So 10 power again 5. I can take 10 power 5 commonly outside, which is nothing but 2 times of that. Okay. So I can say it is 2 into 10 power 5. Got it. So can we see the answer? Like the closest answer we will get. Okay, closest answer you should get. So if you see, yeah, 2.01 into 10 power 5 pascals. So it is 2 atmospheric pressure. So 10 power 5, I can say it's a atmospheric pressure, no. So 2 into 10 power 5 is 2 atmospheric pressure, 2 atm. Okay. Got it? Okay. So I'll end up this session up to this, and we'll continue with the next topic in the upcoming session. Okay. Thank you guys. We'll meet in the next class.